Right, so let's start with our scheduling. So what is scheduling is the first question that we ask is the process of planning different events involved in the manufacturing process. There are three major reasons for creating a schedule: to understand how much of your capacity is already occupied, to identify possible future threats and on-time deliveries, and to help your production, procurement, and sales department work together more successfully. Production scheduling is the process of organizing, planning, and allocating resources, tasks, and timelines to ensure the efficient production flow to meet deadlines. It involves determining what to produce, when to produce it, and how much to produce, while optimizing the use of materials, labor, and equipment. The goal is to maximize productivity, minimize cost, and ensure timely delivery of products. I don't know how many of you have read The Goal. It was a book I read many, many years ago. Eli Goldratt. When I first started in production and management, I was doing a lot of scheduling and trying to get the shop organized so that we would get deliveries on time. We were always rushed. We were always seeming to be late. And then reading this book really helped me understand the process. How do you schedule? What's involved? And of course, the things to look out for when you start off, you always try and schedule everything. You try and schedule to the nth degree. Bottom line is, I learned to slow down and just schedule the components that were problematic. Concentrate on the areas where my bottlenecks were. Eli Goldratt speaks a lot of bottlenecks and how to alleviate that bottleneck. And the theory of constraints made a massive difference as far as my understanding of scheduling is concerned. So if you haven't read this book, I would really recommend reaching out. It's available on Amazon. I think he's just done his 40th anniversary of this book, so it shows you how old I am. Anyway, it's a good book to read. If you get a chance, I would definitely recommend getting a copy. So what are production scheduling? What are the key benefits? Efficiency, it helps streamline production process, ensuring that resources are used optimally and tasks are completed in a timely manner. Reducing costs, this is a massive part for me. The amount of costs we were able to reduce by eliminating waste, reducing idle times. The amount of times that I had machines sitting waiting for product when it was all bottlenecked on a machine before was a tremendous amount of savings that we were able to produce. Improved productivity, it ensures that all parts in the production process are coordinated, leading to a higher overall productivity. Timely delivery, for me, this was massive. We were suddenly able to start delivering product on time without that mad rush in the last few weeks to get things done. And of course, when you're trying to rush things through, that's when mistakes happen, which slow down your production even more. Flexibility allows adjustment in our production plan to accommodate changes in demand, unexpected disruptions. One of the things that we did was we implemented a system whereby we automatically entered a equipment maintenance work orders into the schedule so that we knew that no matter what was happening, our machines were being kept up to date. They were kept working at their optimal position so that we didn't have those unexpected downtimes when the machine suddenly gave in and stopped working on us. And then, of course, better resource management. It helps the effective allocation of material, labor, and equipment, ensuring that they are used efficiently. I apologize if I'm sniffing a bit. I have a bad cold, so forgive me. So what do we need to know to effectively schedule production? 4 things. We need to know what needs to be made. When does it need to be ready? When is this supposed to ship or go onto the shelf or into the next level of an assembly? Who's responsible for making it happen, and what equipment is needed to make it happen, and how long will it take? There's 2 areas of production scheduling, and production planning and production scheduling often get confused. The planning process deals with the most effective way to distribute equipment, operators, and workers, and the material needed to produce your product. Production scheduling deals with the distribution and timing of the process of getting a product manufactured, the resources to be used, and the correct sequence in which those resources are used. We then have to look at what we're talking about versus load versus capacity. Load and capacity are 2 dimensions of scheduling. Load is the total amount of work scheduled for a given resource, and capacity is the maximum amount of work hours a resource has available for each shift of each day and how many units of capacity are available for that period. If the load for a job exceeds the capacity, you cannot complete the job on time unless you assign additional resources to handle the excess load. For example, if you've got a work center that has 3 machines operating 8 hours a day, the work center has 24 hours of resource capacity. If you're scheduling a job, obviously, with 32 hours, well, then you're short of 8 hours of capacity. One of the things I never do is schedule 8 hours in a day. We know that most machine operators, most people run at about 72 to 78% production in a day. So you'll never get to 100%. So I always set up my schedule with, if I have an 8-hour shift, I would normally schedule it for 7 hours or 6.5 hours, because that's realistic what you're getting out of each shift. So the 3 dimensions of a load are which resource, when, and how much. The when and how much dimensions are expressed in 3 measurements: date and time, number of hours, and the units. So in visual, only firmed and released operations of work orders can cause a load. The only exceptions to this are the temporary loads created by online availability of MRP generated planned orders in the schedule other than the production schedule. Excuse me. So let's talk a little bit about capacity. 2 dimensions of capacity. When do you need it and how much are we going to be making? The when dimension is expressed in date and time format. The time dimension, when of capacity, may be different for each day in the foreseeable future. Capacity for each day is expressed in terms of the starting time of the first shift, the number of hours on each of the first, second, and third shifts, and the number of units or dimensions expressed as the number of tasks or operations that can occur at one time. In each of these 3 shifts, for example, is it possible that you work more than 1 shift per day, yet you do not have identical levels of staffing for each shift? We had to be careful with that because we had 2 shifts, but we had a very limited capacity on our second shift. So we had to make sure that we scheduled the lighter jobs on second shift, which made sure we could still get the production out that we needed. So what are the scheduled inputs? These are items or attributes of the schedule itself or scheduling run. Type of scheduling that you're doing, there's essentially 2 types of scheduling: finite capacity and infinite capacity. I always run with a finite capacity because that is the reality. That tells me what I can fit into the shop that I've got with the resources I have. Infinite capacity ignores any of those constraints, and it just tells you when the job could be completed if you had everything available and nothing else in your system to interrupt the process. So let's have a look at visual and the cards, the information that visual looks at in your work order when it determines or when it does the scheduling process. So first of all, it looks at your release date and your want date. What is the quantity? How many items are you manufacturing? And the method of scheduling. By default, visual schedules backwards. In other words, it looks at your want date and schedules your production backwards to meet that want date. If you do not want it to schedule backwards, then that checkbox forward schedule from release date comes into effect. If you do forward schedule from release date, the next date, treat release date as hard, also comes into effect. If you have that box checked, that means that work order will not be scheduled to start when you run your scheduler until that date, your release date is met. And then the final option is your customer priority. Obviously, if you've got sales guys that are promising the world without really caring about your production schedule, they will always try and get their customers with a high level of priority. You can set your priority of your customer order at this point, and you can change the priority of your schedule, your individual work orders. Later on, we will talk a little bit about that. So the next page that we need to look at is your operation detail card. So the fields that we need to fill in here are the setup hours, the time taken to set up an operation, the time taken to run the operation. They're 2 separate fields. So you can imagine if in a previous job where I first started scheduling, we had operators that ran CNC machines on a production level. They were just operators. They knew how to run the machine, but didn't know how to program it. So at the start of each operation, we'd have a setup where the CNC programmer would go out and set up the machine individually and run through the first uh, cut of the machine to make sure everything was working. Then he would leave and carry on with other setups, and then the operators would just do the machining. So that's where you would use setup and run. I typically don't set a different setup or runtime unless they are two separate individuals or resources that are going to be doing those setup and run times. Otherwise, I just set it all up as the runtime, and it eliminates the amount of time you have to record jobs to different fields. So then we've got our run type. There's several run types that Visual gives us. Hours per piece, pieces per hour, minutes per piece, pieces per minute, hours per load, and loads per hour. Obviously, if you use those last two, hours per load and loads per hour, you need to specify the load size in the lower box, which in the moment is grayed out. It only becomes available if either of those last two options on that pull-down menu are selected. Move hours is the time to move, taken to move material between one operation and the next, and minimum move quantity. Those two features are used if you're running a massive production schedule and you're making several hundred pieces and you're happy to move. Once you reach 50, move it on to the next section, for example, or onto the next process, so that you can have the second process running at the same time as the last of your first process is running. So that's where you would specify the minimum move quantity. And if there is a time period between when the product leaves machine one and when it gets to machine two, if it extends through a fair amount of time, then I would put in move hours. Otherwise, I'd leave it blank. In the past, I had to move product from one facility to the next, so it took a day and a half to get to the next facility, and that would be the only time I would ever use move hours. Otherwise, it just simply complicates the process way too much. Your material card is now the next area, and a lot of people forget about the material card when it comes to how am I scheduling my job. Quantity that's required of material for the job, and then most importantly, the lead time and the required date. If you've got material that's only due in a week's time, it's pointless. You try and schedule it into the machine this week. So you have to take that material lead time, if you don't have stock, into account. So let's have a look at some of this in detail. The operation start date and status. If you've already started, released an operation, when you run the scheduler, its completion status is taken into account. If you mark the setup as complete, the setup time for the operation is not scheduled. And then quality completed is compared against the end quantity to prorate the remaining hours or the remaining time you need to complete the operation. You can schedule started work orders first, either freezing or not freezing started operations after they've been scheduled. I always freeze started operations because once it's in the machine and running, I don't want to stop that process because the schedule's found a better spot for something else. I want to try and finish that process and let the schedule do what it needs to after that. So I always set mine to freezing started operations. And then service start date. Obviously, there's some subcontract operations. These are as important as your material operations, in bearing in mind the length of time or the lead time of these operations. So use the service receipt entry and service status function to indicate a date when you ship material to an outside service. When running a new schedule, this date is used to deduct from the required transit days of the operation. Excuse me. Yeah, so definitely when you send material out for a subcontractor operation, be sure to put in your transit days and the lead time, the length of time that product's going to be off your shop floor. Again, you don't want to try and just schedule product that you're not going to see in your shop for another week. Material lead time, we talked a little about this already. If you're using check material availability, the material acquisition lead time enters into the situation the same way as operation lead time does. In this case, material availability constraints the start dates of the operation. Start dates do not change. If you plan on having material available in time for an operation start dates do not change. If you make material available for the operation start, I used to continuously run into problems with my scheduling if purchasing haven't put the correct purchases often leave the required date as the default, which is the same day as the created date, and that messes with the schedule. If it's going to take 2 weeks to get product in, make sure that the required date or the lead time of that material is clearly defined in your part maintenance. Otherwise, it will mess your schedule around a lot, especially if you're doing just-in-time scheduling, where you don't bring in copious amounts of material and leave it on the shop floor in case you need it later. We used to keep our material bins relatively low so that we didn't have excess stock lying around in the yard. So when you're scheduling that way, you have to make sure that your lead times of your material is very clearly defined in your part maintenance, and that the purchase order reflects when you're actually going to receive that material. So let's have a look at the example. Consider special material that's not in stock with a lead time of 15 days. If the current shop resource loading would allow operation to start 5 days from today, checking the material availability pushes the operation out to a full 15 days, affecting all dependent operations as well. So in checking material availability, 4 things are considered. First of all, the current inventory levels might show sufficient quantity to meet the requirements. Critical if you're using the scheduler and you're working on a just-in-time basis, that your inventory levels are accurate. You don't want the system thinking you've got 20 feet of a particular round bar on the shelf. Meanwhile, you don't, because that too will mess your schedule around quite badly. Second, outstanding purchase orders may show additional quantities that you plan to receive. The third is the parts lead time that shows the maximum time you must wait for that material if the current and planned orders do not meet the need. And then the last one is material you're expecting from planned work orders or other work orders in the process. Of course, this material is going to be part of your assembly, so you need to wait for all of those pieces of material to be done before you can include them in your assemblies. So the other option that we've got when we're scheduling operations is what we call concurrent resources. So if you specify concurrent setup and run resources for an operation, these add parallel resource hours requirements to your resources. The capacity and the calendars of these resources are used to schedule in the same way as the primary resource. The calendar of current resources can constrain the schedule of the primary resource. So when I mentioned earlier, I would run concurrent resources with my CNC programmer and the CNC operator when I was running these operations. So you would go in on the advanced tab of your operation setup. You would select the resource that would be running, and if that resource is required for both the setup and the run, and then the duration of that, if you leave it as 100%, both those resources will be occupying that doing that operation simultaneously. You might find this if you have a water jet or a laser cutter that you've only got one operator that can effectively use that equipment. You would have your resource as your water jet and then the operator as your concurrent resource, because then you know you need both of those present to run that operation. If that's not the case, I would not use concurrent resources because it can make for some confusing reading in your scheduling if you're not sure of what you're looking at. Then the other option that you've got is discontinuous operations. So the scheduler supports the discontinuous scheduling of operations. You can set up a shop resource so that operations that use the resource are scheduled discontinuously. You can override the default value set up in shop resource maintenance by editing the operation in the manufacturing window, which is what I've done on the screen. During scheduling, when a load conflict occurs on a unit, the scheduled duration of a run on that unit is compared with the minimum segment size. If the scheduled duration least the minimum schedule size, then the scheduler creates a segment schedule from that unit. Scheduling continues until the collection of segment schedules is found disjointed for time but sufficient to successfully schedule operations duration. So this is going to allow me to schedule if I'm doing a run and there's 200 pieces that I'm manufacturing, and I can set it to schedule discontinuous. If there's a minimum 2 hour window, I can fit anything into that window, and it definitely helps clear up if you're running massive production runs at the same time as you're trying to run just on-time jobs. It definitely helps to have this discontinuous operation set up. So resource minimums and maximums. The scheduler schedules quantities of the same operation to run in parallel on multiple units of a resource. For each operation, you can specify the minimum units required to start operation. The operation is not scheduled unless at least this many simultaneous units are available. So you can also specify the maximum an operation can use. If you don't want an operation scheduled in parallel, specify a minimum or a maximum, of one, and leave the maximum level set to 1 as well. So yes, where we can look at the work order priority. When you run your schedule, the concurrent schedule allows you to prioritize work orders on a scale of 1 to 50. In situations where work orders complete for the same resource, you can decide which one takes priority. So in this window of your file pull-down menu of your concurrent scheduler, you'll select work order priority, and you will see all the work orders that are in your system being scheduled. So you can change the priority. Obviously, if it's set to 1, it has the highest priority. By default, they're all set to 50. This takes precedent over the previous priority schedule for the customer, and this works on a work order by work order basis only. So let's have a look. What does our work order look like? Visual's a little unique in that it allows you to create work orders with these legs, so you can have an assembly, and you don't need part numbers in your system and engineering masters for the subcomponents of this assembly. If this was any of the other systems, you would have had to create 4 work orders to produce the work order that you see on the screen. And that's something I really like about Visual, because it gave us that ability. We were a job shop and we didn't always make the same thing all the time. So this gave me the ability to run my projects in a single work order and track all my material and labor requirements in a single job, which was fantastic because you don't have to have multiple work orders. I've used other systems where you've got 20 or 30 work orders to make a similar part, and it can be really confusing. When you schedule a work order that looks like this, each sub-assembly of a work order is scheduled independently in terms of starting date. The completion of the last operation of a sub-assembly determines when the parent operation can begin, in the same way a previous operation would, where both apply the latest one determines when the next operation will start. The minimum move quantity for the final operation of a leg allows an overlap with its parent operation. So you can see this, each leg will schedule on its own independently, but the operations will see scheduled in sequence. And the material requirements that you'll see are linked to each operation. So at that point, when the material requirements are needed, that's when the Visual will try and schedule that operation in conjunction with that material. So scheduling of the work order. So once you're done with your work order and you're still in that manufacturing window before you even get to the scheduling window, you can run the work order schedule to see the estimated delivery of the finished product. This utility you can use in the estimating window as well as in the work order. So once you've got your engineering master, you can say to it, based on my current schedule, when can I realistically deliver this product? By hitting your file pull-down menu and scrolling down to schedule the current work order. This is what's going to come off that screen. So once you've done that, the schedule will determine if the one date on the work order can be met. Review the work order audit to see what may be conflicts in the schedule. So you can see my work order has been run, and the determinant path delays right at the bottom says this product will deliver 1.104 days late. So the audit will show me where I have a conflict. Typically, what happens when the schedule runs, if you set up to backwards schedule, it'll schedule backwards until it reaches the end. It will then schedule forward if there's conflicts to find a better way of making the system work, and then schedules backwards again. So that's why you see so many operations and so many um, units where it's gone backwards and forwards to try and find the operation. And then there's a little key that you will need to review, which is the results description. So you can understand what each of these columns mean. So the direction is whether it's scheduled backwards or forward. The result tells me what is, what it is. It's material, it's load, and then the start and end date. And of course, if there's any purchase orders associated with material, it brings that into bear as well. These are good screens to look at. As I said, this screen you would look at independent of the actual global scheduler. This is looking just at this one single work order. So now we're going to the concurrent scheduler. This is where Visual schedules your entire production. Every work order in the system that's set to firmed or released will be processed through the scheduler. The concurrent scheduler schedules and reschedules all released and firm work orders in your shop based on due dates and all the priorities you specify. You use the concurrent scheduler to determine several important things about your production schedule: when to begin and finish every operation of your firmed and released work orders, whether given the amount of capacity you have designated for each work center, you will be able to meet the want dates of these orders, and when you can add additional capacity to improve deliveries, and when you have excess capacity for a resource. So a couple of things to bear in mind when you're looking at your schedule, other than the stuff we've already talked about: lead times of material, availability of resources. When you develop your engineering master or your work order, you get to specify the amount of runtime that you get on an operation. The more you run the schedule and the more you process these jobs, the better you'll become at determining or estimating the amount of runtime you need. Visual looks at that runtime that you've specified in your operation when it schedules this job. So if you put your runtime as 15 minutes in operation, it takes 45 minutes. Of course, your schedule is going to be out. So you have to be aware of these things and keep adjusting and keep moving them until you've got the perfect match. And the more you use the scheduler, the better you'll become at it. So what can you can also use the concurrent schedule to create what-if schedules to determine the outcome of various changes in capacity, load, and calendar settings. I love using this. The sales guys love using this in the estimating window, because they can run a what-if schedule and say, if I put this job into my system today, when do I realistically expect it to be complete based on my current workload? And you can lock that for a short period of time so that if you get the order by the end of the week, you can be assured of that. And that'll show you that in a purple or magenta color on your global scheduler, these orders that you've put in that are not confirmed orders, but possible orders you expect to do. And as I said, you can do this directly from the estimating window, custom order entry, and the manufacturing window. The schedule window is, for me, it's an indispensable tool when you want a bird's eye view, a long range view of what has been scheduled in your shop relative to work orders that you have released to the shop floor. Each operation is displayed in a graphical format. You can zoom in, look at specific dates and operations. You can zoom out to get a broad view of the schedule of events. You can view up to 3 schedules at a time on your screen. And you can choose the view you want, and production schedule and what-if schedules. So let's have a quick look at the preferences, because the preferences in your scheduling will determine how accurate your schedule is going to be. And, it's good to go through these preferences. You can leave them as the default. They set the most common defaults, but you want to have a look at these and just understand what you're looking at. So on the concurrent scheduler, on the info pull down menu, there's a preferences option. So let's have a look at those screens that you get. The first one is your options. Schedule horizon. So I've got mine set to 730 days. I would never really set it that far in advance. Normally, I'm scheduling 60 to 90 days out into the future because my production runs are relatively small. If your production runs are long and they extend past 3 to 4 months, then by all means include or expand this schedule horizon into as many days as you need. Fit tolerance, I've got 85% because, as I said earlier, I know that even though I have 100% capacity or 100% attendance on an 8-hour day, I'm only getting 85% or 75% of production out of those resources. So my tolerance I set below 100% because that lets make sure that my schedule is more realistic as opposed to thinking that I'm going to get 100% out of every person every day. Schedule pieces if run minutes per piece is at least, if you've got, you would only put that in if your run per minute, if your run per piece is very, very small. Typically, if it's under a minute or 2 minutes, then you want to schedule pieces to run minutes per piece. You know, if, like I said, if you've got really, really short run times, and schedule only remaining setup time is if the schedule has not been completed or the setup hasn't been completed in the workday. So then we can generate a couple of things from this report once we've run our scheduler work order audit. We can do an operation audit or throughput audit. I normally leave mine to throughput audit. You can specify operation audit and you can see exactly what's happening for each operations. Sort by priority one date, order one date, or priority release date. Again, you'll specify which one you've got based on where your demand is in time. If it's order one date, then specify that radio button when you're setting up your preferences. Once these preferences are set, they're set. They won't change until you come in and change them again in future. Where am I? So schedule started work orders. Normally, first don't freeze started operations or first freeze started operations. I freeze my started operations. If you schedule normally, it'll ignore any operations that have already started and schedule it forward. I leave mine set to freeze started operations. Second tab on the list is the after forward pass. As I said, your scheduler will run in multiple directions. It'll run both forward and backwards, depending on how you set it up. So if you schedule forward on your work orders, you can then say, once it's done a forward schedule, backwards schedule to find if there's any spaces we can fit things in, or you can say do not backward schedule. So it's just an option. I normally leave mine to my production runs always set to backward schedule. I'm sorry, 1 second. Talking too much, my throat's drying up. So I always leave mine set to backward schedule. That's the way our production worked. We worked on a job shop basis. If you're working on a production level basis where you don't have a deadline, but you have to produce X amount of parts, obviously you'll schedule it forward because you don't have that constraint of a date going forward. So the next option that we've got is allocation. So allocation cost, allocate fabricated materials. Fabricated materials are as important in the schedule as the purchased materials. If the fabricated material isn't due in for a length of time, you have to bear that in mind. And then reserve parts for customer orders with desired ship dates before today. This is where you have that argument with the sales team. You're busy building components and he sold one of those pieces you're building. This allows you to determine what to do when in those instances. During schedule, allocate supply to non-work orders first, to work order requirements first, or based on a date sequence. Excuse me. This is simply how it's going to allocate that material supply. If you've got a sales order open first, does it take the sales order? Does it take the work order? I've select mine to based on sequence, based on the date sequence, and then create material supply links for supply within project warehouse, universal warehouse, or allocate supply. If you're not running projects, I very seldom select any of these options. Normally, you would have your warehouses set up, unless you do run special projects, then you would have project-based warehouses or universal warehouses. In most organizations, you simply have one warehouse, and so I would leave those buttons unchecked. And then material is the last tab. Part IDs, associated warehouse, then set universal. I always check material by part ID. Again, if you've got associated warehouses and universal warehouses, then you may select an alternate option, but I always select it as part ID, and then use inventory supply first. If you've got stock, it will use that stock in the schedule, as opposed to any purchase orders that were outstanding. So those are your preferences. Let's have a look then at the scheduling process. After you set up and verified your shop resources and part lead times, you can begin the scheduling process. This involves the following step. So scheduling the job, start a concurrent scheduler, set the current schedule preferences, which we've just looked at, create a new schedule, activate an existing schedule. If you haven't already created a schedule, you'll find that off your site, the pull down menu of the admin. And then you can specify your schedule that you're going to be working on, or you can specify, that is where you would turn on a what if schedule as well. You can select the appropriate scheduling options, and then you hit run schedule. Once you've run the schedule, you will open the scheduling window to see your results. Load the schedule you just created and then view it. So this is what your concurrent scheduler looks like, the scheduling window. So you'll see next to B assembly, I have two white boxes, one below the other. That tells me I have two resources available on my first shift for this job, for this position. Shift number 2 and shift number 3 have 0 capacity. So each of these boxes indicates the capacity per shift. And that's detailed in the image on the right. First shift, second shift, and then if you've got multiple resources, of course, there will be one box below the other. So there's some standard conventions and abbreviations when you're looking at the job, and you will see that in your work order or in your scheduled boxes, you'll see different configurations. So this is where you find it. The standard abbreviation format is used when operation appear in the schedule to indicate the work order, base ID, lot ID, split ID, and sub ID, operation sequence number. So you'll see this work order base ID will appear just like this. When the sub ID and the split ID are 0, they are omitted from the abbreviation. So your operation 40 of sub ID 0 of work order 4009, lot 2 split 0 appears, as you see at the bottom there. And the more you use this, the more you will be able to understand exactly what all of these terms and conditions mean. So on that schedule, you will notice there were different colors. So the colors that each operation bar looks at will will tell you what that operation is looking at. So if it's cyan or blue, it's on time. The work order operation will be completed before the work order 1 date. If it's orange, it's on time. It's normally a project task available to project license users only. This task will be completed before the project 1 date. Purple is an on-time planned order operation. So that order I was telling you, if you've run a what if and it's a planned order but not yet in the system, it will show up as purple. Red will be, that is on just-in-time work order operation. The operation finish date is after the 1 date. So in other words, this one is late. A dark orange, or that will show late. This is also a project only color code for your scheduler. If you're not running project, you will not see these orange and yellow tasks. Dark purple, a late or just-in-time planned order operation. Blue is a frozen work order operation. Frozen operations cannot be scheduled. If you've got an order that's been cancelled, been put on hold, you can freeze it, and of course it freezes it in the schedule. Brown is a frozen task. Again, if you don't run projects, you won't see the brown. Light yellow indicates you've selected a work order operation or project task. If the text is blue, the operation task is frozen. When you select an operation or task in the system, highlights the dates at the top of the scheduling window that work order is scheduled to occur on the operation or the task. The system also highlights the resource to the left of the window. And dark yellow is, of course, if you've selected a work order and you want to, or project task that is late. So you can highlight particular work orders and see where that particular work order is throughout the system. Operations or tasks, green is an operational task or path of the determinate path and is on time. And then, of course, dark green is if it's going to be late or not on time. So let's have a look at the home option. If you're moving around the screen and you've got a couple of, you can hit the home from the pull-down menu and it will zoom back to the date as set as of date. So you can specify your schedule to show a particular date range. You can zoom in and out as tight as you want it to make sure it's easy to see the load exerted by short operations. You can use this option to maximize to a maximum of 6 times in succession for the default resolution. So you can go in really, really tight, but not all the way down if you've got really short operations in amongst long operations. And then you can zoom out to see as much of the screen as you want to. So holding down the control and the down key, then use the mouse wheel to adjust the zoom level so you can roll your mouse button backwards and forwards. I kept my schedule relatively short. As I said, I kept it for 90 days because we were doing production runs on customer equipment that came into our shop. We normally never ran a job over 3 months. If we ran beyond 3 months, obviously I would extend that to further out, but otherwise I will keep it to as long as my current job is running. So let's have a look at shop views. If you want to set up only how am I doing for time? Whoops. If you only want to see a small section of your equipment, so when the scheduler runs, it runs the entire schedule for every resource in your system. One of the things I found is that it can be quite confusing and quite daunting to look at all of that at once. So what I did is I set up shop views, which limit the view that you will see on your schedule to just those few machines that you know you always have problems with. For me, it was always the CNC machines. They were always backlogged. There were always a reason why. There was always something going on in the machine shop that needed attention. So then I can select a shop view. Once you've selected the shop view, you can define the pieces of equipment that are in that view. And then when you select your schedule, you show only that view. And that limits your schedule to just the machines that have currently got resources in that selection set. When you're facing problems and you've always got one section of the shop that's kind of holding everything back, or is your bottleneck, it's good to be able to focus on just that portion of the shop so you can see exactly what's happening and ignore all the rest of the noise of the schedule. So a couple of reports you can get out of your production schedule. The production schedule report is off your scheduling pull-down window, and you'll see a series of 6 or 7 reports that you can access on this window. Shop resource dispatch report. That is you'll select the start and end ID of your resource, and this is what your shop foreman or your planners are going to be using to see what is on each resource, what is expected on each resource for a period of time. These are good reports. They're really interesting to be able to go through and see exactly what work orders and operations are going through your schedule at any given time. Work order schedule status report will tell you which work orders are. It will give you just a page of all your work orders with one date, finish date, the status and whether it's going to be late or early. Nice if you're running production meetings, you can have this as a printout and it's live and giving you the exact information you need. Performance printing the performance report. This is a simple report that you can specify your resource, and so you can hand this to the foreman and say, this is your list of work orders or jobs that need to be completed in this week or in this day, and then they can sort it whichever way they want to, as long as they know what needs to be done in the time frame that they've got. Shop calendar is a simple resource calendar view that will show you the allocation of resources throughout that week. And then printing resource employee efficiency utilization reports. There's a couple of reports based. You can sort by resource, you can sum resource, you can sort by employees. That'll just show you the amount of capacity that each of these resources or employees have consumed during that period. And then, of course, the final one is the printing shipping performance report. Again, it will just show you all the stuff that's gone through your shipping department. You can sort it by order ID, customer ID, or customer name, part ID, work order ID, or product code. Printing the shop floor status report will give you a status report, displays the work order status associated with resource details on your shop floor. It displays the information of the work order, the part, estimated in quantity, estimated out quantity, actual quantity out, scrap quantity, and yield percentage and available quantity. So that is my presentation. I managed to squeeze it right in on time. I hope this will give you a glimpse of what visual scheduling capabilities are available. It's highlighting some of its operations. Beyond scheduling, Visual provides a wealth of features and insights to enhance efficiency and profitability in your shop. If you'd like to know more, contact the office, schedule an appointment. We'd love to come out and explore how we can help you guys make the most of the software you've got and get the most out of Visual. So thank you very much for your time. I do appreciate it. Hopefully I kept you entertained for the last 45 minutes. Back to you.
Okay, thank you so much, Stephen. It was a great presentation. We have a couple of questions from Thomas. Our first question is, where would I use concurrent resources on an operation?
Where would you use concurrent resources? Like I said earlier, if you've got a water jet and only one operator who knows how to use it, or a CNC machine that there's only one operator who knows how to program it and run it, then you would run both resources as concurrent. You'd have the CNC machine or the water jet as your main resource, and the operator as the concurrent resource. You have to bear in mind that if you set that as a concurrent resource, both resources have to be available at that instant for the scheduler for that schedule to run.
Excellent answer, Stephen. The whole vision about concurrent scheduling is, there are more than one element in regards to a constraint. For example, you were mentioning a CNC machine. Maybe there's a tool that CNC machine requires. Sure. And if that tool is used at a different CNC machine, then this one cannot be scheduled. The example Stephen used was, a number of skilled employees for a work center. If you've only got one skilled employee, but you have two machines, only one of them can be scheduled at a time. And the system automatically knows that and schedules around that.
Thank you, Andy. And we have another question from Mike. For freeze operations, how to have two operations back-to-back frozen? CNC side 1, then side 2, they're related operations based on large pieces staged in work area.
I'm gonna have to get back to you on that one. Normally you would freeze your operation. Let me get back to you on that one. I would have to come back to you on that.
Would you mind describing your question a little more detailed? I think what you're saying is 2 operations sequentially scheduled, both frozen. Is that what you're saying?
Mike, if you could.
Two to three machines at the same time, long run time. So use second machine at concurrent time. By the way, Mike, you can call me anytime and I'll give you advice on scheduling anytime, my friend. Okay.
That's another question, Andy.
Yeah, I know.
Regarding
That's the second question. The one before that we're got to be answering next.
Stephen, will you go back to that question in your presentation for freeze operations?
I haven't got the details on that in my but I'd like to get Mike's details, and then I'll just come back to him with that. I don't have a solid answer for you right
that's
now.
okay. I can, Mike, you're welcome to call me anytime. But your second question regarding concurrent scheduling, what about a person who could run 2 or 3 machines at the same time? Long run time, so use a second machine. You're answering your first question now here. On the first one, setup is done, then run operation 1 for all pieces. Then move chucks, run operation 2, then move parts out to machine center. Mike, give me a call. I'll answer it for you. But in regards to your previous, scroll back up here. Let's see. Can I scroll back up? I can. Regarding concurrent scheduling, what about a person that runs 2 or 3 machines at the same time? Yeah, you can have the same person running on multiple machines. Maybe there's a setup, or maybe it doesn't need anybody to watch the run or something like that. That's all defined in the background, so the system schedules it appropriately and exactly.
Yeah, I would just schedule the resource. The machine would be 100% scheduled, and the primary resource, and then the concurrent resource would be the operator, and I'd divide it into 30%, 30%, 30% on his availability on that
or even
machine.
33 and a third %.
Or even that.
But yeah, that's what's so amazing about Visual Scheduler, is that it's going to be able to handle every nuance. And if you set it up appropriately at the beginning, it's really not that difficult to use.
Yeah, and
you'll need somebody like Stephen to help you maybe at the beginning, but once you have it live, the really amazing thing about Visual Scheduler is that, especially using the what if scenarios, you'll be able to increase your shop throughput without increasing overhead, which is what everybody's trying to do, right?
Exactly. And the one thing that I could say, maybe the one biggest takeaway is if you're starting scheduling now for the first time, look at narrowing your field of view down to just the machines or the equipment, the resources that are causing you a bottleneck at the moment, and concentrate on those. Once you've got that really defined and you understand exactly what's happening in that schedule, then open it up to the rest of your resources so you can see the whole picture. But when you look at it for the first time, it can be quite intimidating, especially if you've got a lot of jobs and a lot of resources and operations running. It can be quite intimidating. So it's narrow that field of view down to the resources you really want to concentrate on and go from there.
Okay. I'm seeing if we have another question. Thomas asked another question during the presentation, how far into the future we can develop our schedule. Andy answered this question from the chat, but if you have any additional comments, Stephen, please feel free to answer.
Yeah, 6 months is, you can go up to skate by 6 months in advance on your schedule. Would I go that far? Yeah, you can. You can go, like I think I've set mine up to 720 days. So you can go a fair distance into the future. I've never gone to the end and it said to me, you can't go that far into the future.
I don't think there's a limit, Stephen.
I don't think so. I've never
you just have to define the start date of your scheduling horizon. and
Correct.
you can see up to 6 months at the same time, but
Yeah.
really the schedule still keeps going on and past that.
Past that, yeah,
You just have to scroll to see further into the future.
exactly. Like I said, I always keep it. My rule is keep it simple, stupid, and look at the stuff that's important and the next 30 days maximum, because that's where you can make an effective change. It's good to be able to see out for the next 6 months or a year to see what's coming down, so you're not taken by surprise of something that's going to happen in the future. But definitely focus on the here and now would be my advice.
Okay. I think we don't have any other question. Thanks again to everyone for joining us today. We hope
I'll
you
just end
find
it
the-
off by just saying, scheduling is one of those functionalities every ERP system in the planet claims to provide. The difference between visual is that it accommodates all the nuances. Of course, you set them up at the beginning, but all the nuances so that the schedule forecast is accurate. It's real. And when you're looking at the schedule at this moment in time, you know exactly what's going on. You know exactly what you have to, which constraints you have to fix proactively. And basically, bottom line, you're able to make more with less.